Continuing with number 4. For each interval below, give a value t that is in the interval. This interval that we have, remember, it's already set up as smallest to largest. In every book that you see and in every math notations you'll see, it is always from smallest to largest, and you should write it like this too. Because we know that fact, we can also read this that t is between 0.82 and 0.97. So it's in between, and it does not include those two values. So it's just going to be from, here, some values in between, and 0.97 here. Where is 0 at? These are both positive, so 0 is somewhere over here. So we see that it's going larger this way and then smaller this way. All of this is important. You have to stop and think to see where this number is at. Now let's address the question. It says, give a value that is in the interval. So we want a value that is here. Let's find a value. Well, what I can do is, in the comparison that we had earlier, where I was listing these numbers, and I had 0.97, I start seeing that this is where the difference is at. So to have a number in between, then I would probably put 0.8, or you could do 0.97 as well. But so now I'm going to have a value in between, and I'm going to go 0.8. See, and I'm comparing it to this one, so see, now they're the same. And then the next value I would compare would be this one, and so I need a value here. I want this new value in pink to be larger than the 8200ths, the 0.82. So I need to have a number that's larger. What's larger than 2? 3. What number could I have also done? I could have also done, let's do another one. I could have also done 0.9. And now I would be looking at a value here, 0.9. You see I'm comparing these two. And then the next value is 7. So this value has to be smaller. So I could have done 6. And you can play with all those numbers, right? So just pick a value from here. So I would say that the values 0. I'm going to go with the first one we did, is in the interval. Like I mentioned earlier, if you can eyeball a value and you do not need a comparison, I'm going to call this over here, this step is called a comparison. If you don't need a comparison, then by all means, just give me the value. But if you need a comparison, then now you know how to do it. You try B. Number 5, graph each interval using the appropriate notation, and we have the parentheses. Recall that this is not included, and the brackets are included. What does it mean to include something? It means that value, let's say if we include 4, 4 can be the answer. If it does not include 4, then 4 cannot be the answer. It has to be smaller or larger. Take a look at A. Now, I usually start at 0. I'm going to put 0 here, and I'm going to go to the right because both of these values are positive. They're quite small, so I don't take the time as I usually would to place them appropriately on a good scale. Usually I tell you, okay, this line is 5, 10, 15. Because these values are so small, I don't do that. But you should still be reasonable. You can't have them all over the place or one be on the left side of the negative or, be on the wrong things like that. So be reasonable. And then we're going to use the parentheses because the values are not included. Now this is enough, but if you wanted to provide even more context and say that this is your interval, then you can do the shading. I think no shading is enough and it's okay. You try B. Don't forget that those are both negative. Let's go on to 6. It says graph the interval P less than. It is so important that you know how to read this. If you don't know how to read this, then it throws off your whole work. Graph the interval P, which is less than 0.03 or 0.03 on a number line by using the appropriate notation. and shading the appropriate side. This case, they're asking us to shade specifically, so I will. Plot P is equal to 0.005 or 5 thousandths on the number line. Is P 5 thousandths inside the interval? All right, one step at a time. Let's go ahead and graph the interval. P is less than 0.03. So I'm going to put down a 0. And I'm going to notice that 0.03 is to the right because it's positive. I'm just going to put it, let's say, right here. Remember that I'm not being very specific about the space, but I am being reasonable that it has to be to the right. So we have that our P is less than this. What values are less than 0.03? Anything this way, right? Less. So let's go ahead and use our line this way. And it says to shade, I will give you the option. So we're using the appropriate notation. I will give you the option of giving me a nice thick line, or you can also use these lines here to shade. Okay, so we've shaded. We use the appropriate notation, and in this case, it's not included. Plot the p-value of 0.05. So I want to know if 0.05 is to the right or to the left. That is the question. So let's compare. We're comparing 0.03 compared to 0.005. Start with the 0, they're the same. Go to this 3, go to this 0, and this is greater. They're positive, so we pick the correct sign, which is 0.03 being greater. That means 0.005 is to the left of 0.03. So let's go in there and draw in our 0.005. Now I want you to be considerate of the intervals. If that's 0.03, I'm going to make that 0.01, 0.02. And so 0.005 would be in between this value right here. Now, why do I want you to consider that? Because if you give me a 0.5 all the way over here, then I will mark that wrong because you're not being reasonable as to the location of that value. So make sure that you are reasonable. Let's mark all of these. Right, so it says plot the p equals 0.005 on the same number line we did. Is p inside the interval? Well, because we put all of this beautiful picture together, we know that p equals 0.005 is inside the interval. Well, part of this is your answer, all of it. It asked you to graph, it asked you to shade, it asked you to use the correct notation, and it asked you a question if it's inside the interval. So all of this entire thing is your answer. Please do the same for number 7.